Okay. Good morning, everyone. Welcome to my presentation. So the topic is I am going to present a literature on pattern mining algorithms in big data. So I am Rage Uday Kiran. You can call me Rage. I belong to Database Systems Lab. I have expertise in data mining, big data analytics, recommender systems, and ICTs for agriculture. So my website is given here. We also have a open source toolkit called Pattern Mining Python Kit. Okay, the URL is presented here. So my research topics are pattern mining algorithms that I am going to present in this presentation are all available in this page. Okay, so you can go to this link, download the code, and you can work on them. So my outline is as follows. First, I will be introducing you to frequent pattern mining. So, in my perspective, I feel frequent pattern mining is the most easiest model to learn in the entire machine learning and data mining. The reason is if you are familiar with sets, it's very easy to understand the meaning of a pattern. Okay, so we'll see how simple it is. Okay, definition of a pattern. Once we understand the meaning of a frequent pattern, we will look at the search space. Then what are the algorithms we use to find frequent patterns? Okay. Once we do this basic introduction about frequent pattern mining, we look at the very advanced topics, which are frequent spatial patterns, periodic frequent patterns, high utility patterns. Next one is fuzzy periodic frequent pattern. Okay. So these are the hot topics. So in the first hot topic, we exploit spatial features and then periodic features. Okay. So this is how we go. And these are our publications in recent publications in top conferences. Okay. So these are all Core A conferences, very prestigious. So anything you touch in these algorithms, they will easily go to a very good conference or a journal. It's up to you to decide. So let's talk about frequent pattern mining. So I am taking a use case here. So let us take market basket analytics. For example, let us assume there is a supermarket which sells lots of items. Okay. So people go to the supermarket and purchase some items. Okay. So our purchases will create something called market basket database. Okay. So we can say the one person, okay, whose identifier is one, has purchased bread and jam. The second person who came to the supermarket has purchased bread, ball, pen, and bat. Okay, and so on like this for 10 customers. Okay, you can instead of supermarket, you can put any e-commerce application also, Yahoo Japan's auction data or Amazon data. They all exist in this form, which is called market basket data. Remember this word, this is very important to use. Then once we have this market basket data, okay, the data analyst, he wants to know what are the frequently purchased item sets. He is not asking for frequently purchased items, okay. He is talking about item sets, okay, that is combinations. So we call these item sets as patterns. Now let us generalize this use case, okay. So we have a real world application that is producing data. Okay, in this data, there is competitive information that is beneficial to the users. The data analyst, okay, wants to extract useful information from this data. So he is asking, extract interesting patterns in the data. Okay, so in the past, okay, before 2000, okay, here we only had statistical tools. The problem with the statistical tools is they cannot handle, okay, megabytes or terabytes of data that was being generated by e-commerce applications. We called that problem as data rich but information poor situation. Okay, so what from 2000 onwards, what we did is we came up with a concept called periodic pattern mining to perform analytics. So we have real world applications that produce data. This data will be given to a frequent pattern mining algorithm, and the algorithm will output the interesting patterns for the user. So we call this as knowledge. So now we look at what is this pattern mining algorithm and how it will extract the interesting knowledge. So the model is very simple, okay, only 4 lines, okay. Assume we are having some items, okay, I1 to In. This is the mathematical model, okay. A subset of items is called a pattern, okay. If a pattern contains k number of items, it is called a k pattern, okay. The support of a pattern is basically frequency of the pattern in the database by the size of the database. Let us see an example so you can better understand the mathematics. Okay, I am giving you a transactional database. Okay, so it contains 20 transactions. Okay, now the set of all items in the database are A, B, C, D, E, F, G, and H. Okay, so these are all the items that are appearing in this database. Now we say a set of items, okay, AB, ABC, all combinations, okay, are patterns. So this pattern contains 2 items, okay. So we call it a 2 pattern. Now let us look at the number of transactions that contain AB. AB occurs in 1, 4, 7, 10, 11, 13, 16, and 19. So it appears at 8 transactions, okay. So we say 8 divided by 20, which is nothing but 0.4 or 40%. It means AB has appeared in 40% of the transactions, okay. If the user specified minimum support is 35%, then we say AB as a frequent pattern because the support of AB is more than the user specified minimum support. Is this point clear? I prefer interaction. So if you have any problem, let me know. I will explain, because once once you are clear on this topic, other things will be very easy to understand. You have any difficulty, then type it, or type it in the chat, or you can ask me again. Okay, so you don't have any problem. Okay, now tell me, I am asking you a question. Okay, find the support of AC in the database. I am putting the chart. Find, let me know the support of AC. Okay, let me someone find the support count. Let me know how much is the value. I will be waiting for your response. Okay. No, it's not 8 by 20. AC is 3, right? No. Let us look at the TIDs containing AC, okay? Not here, not here, not here, not here, not here, not here. Yeah, 6, that is 1. No, here 2, here is 3. So AC have appeared only 3 times, yes. So is 3, you can simplify for ease of talking, we can say 3 times, okay? So this is called 3 times. So 3 by 20 is the answer, okay? So our objective is to find all the combination. Okay. Next, next question is what is the size? Okay. A, B, C, D, E, F. What is the K value of this pattern? Okay, I gave one more question, so you can answer. What is the K value of this pattern? K is nothing but number of individual items within that pattern. So what is the K value? I put in the message. You can type it. What is the K value? Let me type here so you can understand. Okay. Yeah, I'm giving you A, B, C, D, E, F. Okay. What is the K value? Can you see my screen? What is the K value here? Yes. It's the total number of items. So K value is 6. Correct. 6 is the right answer. Okay. Now let's go to the topic again. Okay. So now you understood what is a frequent pattern. Okay. So very simply, given a set of items, you want to find the combinations that are occurring frequently in the data. Simple problem, okay? So our objective is we have to find all frequent patterns in a transactional database having support no less than minimum support. We have to find it, okay? So this is the simple model. Now let us look at called search space, okay? So assume I am giving you 4 items, okay? A, B, C, D, okay? All the combinations, okay? These are 2 patterns, 3 patterns, and 4 patterns. All the combinations of A, B, C, and D is called item set lattice, okay? So what we have to do is, we have to perform search on this lattice to find frequent patterns. Can anybody say what is the size of this item set lattice? What is the size? To see your chart. You can count size means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and this is null is 16. Okay, this is empty set, which is the set of every set. So the size is 16. Okay, given 4 items, the size is 16. So the relationship is 2 power n minus 1. Okay, this is the search space. Now what you have to do is we have to perform search on this huge search space to find the all frequent patterns. So how do we reduce this search space? We use something called yeah. So we use something called a priori property to reduce the search space. So what does it do? If a pattern fails the test, all its supersets will fail the test. Okay. So here I am giving you the support of the patterns in counts. Okay. Assume support of bread in the database is 5. Support of jam in the database is 3. Means, okay, support of butter is 4. Okay, so bread has appeared 5 times in the database. Jam has appeared 3 times in the database. Butter has appeared 4 times in the database. Now, my question is, how many times bread and jam may have appeared in the database? Can anyone tell me how many times? Maximum number of times bread and jam can together appear in the database. How many times bread and jam might have appeared together? I am having some bug, it seems. Chart is not appearing. 3. Yes, correct. 3 is the right answer because jam has appeared 3 times. Let me close this one. Okay. Jam has appeared 3 times. Okay. So bread and jam can at most appear 3 times in the database. Similarly, for bread, jam, and butter, they 3 can appear at most 3 times. Okay. So if I know the lowest one, okay, the support of the lowest one, I can predict how the things will happen for the supersets. Okay. So in this case, okay, jam is 3. So bread jam can appear 3 times. Bread, jam, and butter can appear 3 times. Now, if I say minimum support of 3, okay, then we can say bread jam can be a frequent, maybe a frequent pattern. Bread jam butter can be a frequent pattern. Okay. Now, if I specify minimum support as 4, then what we can say is all supersets of jam will be infrequent. So how do we do this? Okay. So let us assume we start from here, top, we go to A. Now, if AB fails the test, okay, then all supersets of AB will fail the test. Okay, so we don't have to go down. That is the advantage of a priori property. Means if you know one has failed the test, we know all the others of other supersets have failed the test. This is the advantage of a priori property. We will be using this to mine all frequent patterns. Okay. Now, how do we perform search? We can perform the search in two ways. One is breadth first search, the other one is depth first search. Okay. In this class, I am focusing on breadth first search algorithm. Okay. So if you have, when you have time, please go through depth first search algorithms. Okay. I am explaining breadth first search because it's very easy to understand. Okay. So let us look at the breadth first search algorithm. Okay. The breadth first search algorithm is called a priori algorithm. Okay. It uses the strategy called candidate generate. Okay. So you generate a candidate and you test those candidates to discover frequent patterns. Okay. So it has two steps. One is a join step and another one is a prune step. In the join step, what we do is we generate candidate K patterns, okay, by joining frequent K minus 1 patterns. Okay. In the prune step, we will prune candidate patterns to find frequent K patterns. How do we do this? Let us look at the example. Okay. Let us assume minimum support is 3. Okay. Now what we do is first we gather all the items in the database. Okay. And we scan it. Okay. So we know the support counts. Okay. So A appeared 12 times, B appeared 9 times, C appeared 9 times in the database. Once we know the counts, okay, of all the items, we use a priori property, okay, to prune uninteresting patterns. So you see minimum support is 3. H has only support count of 1. So we prune this one because all supersets of H will have only 1. So we prune it. Similarly, we prune G because G support is less than 3. Okay. Once we do this, we extract L1, that is frequent 1 pattern. So the frequent 1 patterns are A, B, C, D, E, and F. Okay. Once we find these frequent patterns, okay, now we join them. Okay, so we generate C2. Okay, so we join L1 with L1 to generate all combinations. Then what we do is we scan the database again and we measure the support counts. Okay, we know the minimum support is 3, right? So from C2, we prune C2 and generate L2. Okay, so A, B, A, C. Okay, I think I forgot. AC will also come here. Then AD will fail the test, AE will fail the test, and so on. Okay, so we generate C L2. Okay, from L2 we try to generate C3. Okay, C3 is L2 joined by L2 itself, but we don't join because AB don't have BC or AC to combine. So we stop here and we say these are the frequent 2 item sets and we stop the algorithm. Okay. So any problems in understanding a priori? If you don't have any problems, then please answer this question. Can you identify any problems in the frequent pattern model? You are given 2 minutes time, so you can tell me what are the problems that you identify. So did you find any problems in the frequent pattern model? You don't find any problem? Okay. Okay. Listen. When we are talking about frequent pattern model, we are looking only at the frequency of a pattern. We are not looking at various characteristics of the pattern. Okay, so that is the flaw of this model. Okay, so what are the characteristics of a pattern? A pattern or items, okay, can be spatial objects. If you have spatial objects, then how do you determine the interestingness? Okay, frequent pattern mining don't understand it. Okay, that is the weakness. Next, frequent pattern model do not consider, okay, temporal information of an item, how regularly a pattern is appearing. It does not understand. Next problem is frequent pattern mining model assumes data is binary form. Okay, but in the real world, okay, data is not binary. It has some value to it. Okay, so all these important features are ignored by frequent pattern mining model. So now let us look at some advanced topics that try to reduce this problem. Okay, so these are the problems. Okay, it ignores spatial information, it ignores temporal information, it ignores values of the items. Let us see how we can improve it. Okay, so this is our recent publication that we did it in this year. So from anything that you can do on these algorithms, we'll go through a very good conference. Okay, so you can try to improve them. So let us look at frequent pattern mining, frequent spatial pattern mining. Okay? So uh, you can see, okay, in the Japan, okay, we have atmospheric air pollution measuring system called Soramame. They have set up ground stations. Okay, sensor network was kept throughout the Japan to monitor air pollution. So these sensors will generate the data, okay, at hourly intervals. So at 00 hours, sensor 1 has recorded 74, okay, micrograms of PM 2.5. Similarly, we get this data, okay, at each sensor, how much value we are getting. Then what we can do is we can simply transform this data into a temporal database or a transactional database. Okay, at 00, 1, 2, 8 have appeared. Okay, at 1 hour, 5, 9 has appeared. So we can create a transactional database like this. Okay, and we can input this transactional database to a frequent pattern mining algorithm to find two patterns. Okay, so I am showing you two patterns. Okay, one is the red pattern and another one is the blue pattern. Okay, red pattern and blue pattern. Now tell me, are both patterns equally interesting? Which pattern is interesting? Both are interesting. Are only red is interesting or only black is interesting? Let me know. Okay, I am having some bug here. Zoom is not working on me, so I will come back here. Yeah. So let me know which both patterns interesting or only one pattern interesting. If it's only one, then what is the color of the pattern? Okay, these are sensors. Black color are the locations of sensors. Okay. Similarly, red points represent the location of sensors. Come on, choose the color. It's very simple, right? Okay, one said both are interesting. Okay, I will explain again. Okay, there is a sensor network. Okay, the sensor network is giving you some data. Okay, we applied frequent pattern mining on the data. Okay, we got some patterns. Okay, so what does each pattern say? Each pattern is saying people who are living in those sensor areas are exposed to high levels of pollution. Okay, now the black pattern says that people who are located at these black places, okay, are exposed to high levels of pollution. The red pattern says people located at these sensors are exposed to high levels of pollution. Now, which one you feel is interesting? No answer. See, when we are talking about the black pattern, okay, the locations are very far away from each other. Okay, so this pattern is giving us incorrect information, saying that people in entire Japan are exposed to harmful air pollutants. Okay, which is incorrect. Okay, on the other hand, the red pattern, which is close, okay, it says that people who are living very close to these sensors are exposed to high levels of air pollution. So when you see here, the red pattern is more interesting because many sensors are exposing to high levels of air pollution. So when we take the spatial information, okay, the items have to be close together to be interesting. If they are very far away from each other, okay, it is not so much interesting to us. Okay, but frequent pattern mining cannot handle such level of information. Okay, so what we do is we propose the model of frequent spatial pattern. So let us see how that happens. Okay, so this is our argument. So given two spatial locations, okay, two patterns, frequent pattern model says both are interesting. However, the reality is only the red pattern is interesting. So let us look at the model. Very simple. So we have some items. Okay. So each item has some point information. Okay. So let us call that point information as a spatial database. Okay. So A is at 0, comma 1, B is at 2, comma 1, C is at 1, comma 0. Okay. So like this, we have spatial coordinates for the items. Okay. Now X is a pattern. Okay. Now what we say is X is a spatial pattern if the distance between its items, okay, the maximum distance between its items is less than the user specified maximum distance. Okay. So for distance function, let us consider Euclidean. Okay. For distance functions there are many functions are there. For our class, let us consider Euclidean distance. Okay. So the Euclidean distance between AC is 144. Okay. So if the user specified maximum distance is 1.5, then we say AC as a spatial pattern. Okay. Now I have one question for you. Let me know whether AB is a spatial pattern or not. Okay, please answer whether AB is a spatial pattern or not. Calculate the Euclidean value of AB and let me know. Okay, I will wait for 3 minutes. You can Google the net for Euclidean if you don't know. Okay, and let me know. What is the Euclidean distance between AB? And is it a spatial pattern or not? Any other answers? The condition is distance should be less than the user specified. It should not be more. See, when we talk about minimum support, we are using minimum there. Here we are using maximum. So it should be less. Your distance should be less. Yeah. So AB is not a spatial pattern. Yes. So AB is not a spatial pattern. Correct. Okay. So only AC is the spatial pattern. Once we know, then it's the concepts are very clear. So the frequency remains the same. Okay. Now let's go to the, okay. So now we have a temporal database. So which is nothing but a, instead of TIDs, okay, we can have timestamps. Okay, now we have this database. So the support of AC is 7. Okay. So if the support of the spatial pattern is more than the user specified threshold value, okay, we simply call it a frequent spatial pattern. That's a, okay. So this is our recent work. So you can propose much better algorithms to find such patterns. Okay. Now let's go to the interestingness. Okay. So when we apply our model on the air pollution data, okay, you can see the points are close together. Okay. You see, that's how good our model can identify. If we remove the distance function, then the patterns get spread all across. Okay, they become meaningless. But now there is a clear distinction between the each pattern. Okay. Now let us look at something called periodic frequent patterns. Okay. Now let us take a different example. Sorry. So this is the road network. Okay. So this is the Kobe area in Japan, on which sensors were placed to measure congestion. Okay. So these sensors will generate data. Okay. They generate at 5-minute interval. Okay. I am not considering spatial information in this paper. Okay. I am only talking about time. So now what we did is we are converting this data into time. Okay. We have this temporal database. In this temporal database, okay, there is useful information that is hidden. Okay. Now you want to find it. So let us take the real world scenario. Okay. Assume now the time is 8 a.m. Okay. Wherever you are located at, let us assume we are at 8 a.m. Okay. We have a typhoon forecast for the next 1 hour. Okay. So at 9 o'clock, this is how the typhoon is going to be. Okay. The rainfall is going to happen here. So the traffic police, he wants to know, find the road segments in which regular congestion was observed between 8 hours and 9 hours. So this is his requirements. Okay. So how do we do this? Okay, we do it using periodic frequent pattern mining. Okay. So what we try to do is we generate the data, temporal data, we give it to the frequent pattern mining model. It will tell you some patterns. Okay. You interpolate these patterns on the rainfall data. Okay. And based on that knowledge, you take a decision. Okay. So you can see we are observing congestion here, but there is no rainfall, high amount of rainfall. So we can ignore it. But if you see here, okay, here we have found several patterns and congestions are being observed here. So we can focus much attention on this part. So how we do this? So very simple. Again, we have items, we have a pattern. Okay, now we have a temporal database. So in the temporal database, we have timestamps. Okay, 1, 2, 3, so on, and items. So in our case, items are nothing but sensor IDs. Okay, we have this kind of temporal database. Now we do is we collect the timestamps at which a pattern has appeared. Okay, so AB has appeared at 1, 4, 7, and 9. So what is the support of this pattern? Can You answer now. What is the support of this pattern? Type your answer here once again so you don't forget. What is the support? Oh, it came here. Okay. I am encountering technical issues. Okay. So the support of the pattern is 4. Okay. 1, 2, 3, 4. If the minimum support is 3, we say AB as a frequent pattern. Okay. Now let us measure the periodicity of the pattern. So how do we measure periodicity? We measure the gap. Okay. The pattern has appeared at timestamp 1. So 0 minus 1. So that is the gap. Okay. Next is 4 minus 1. That is 3. Next is 3. Next is 9. Okay. 7 minus 9 minus 7. That is 2. Then from the last transaction. Okay. That is 1. Now we take the maximum of this value and we say periodicity is 3. If max period is 3, then AB is a periodic frequent pattern. So in this way, we find the periodic frequent patterns. Okay, now let me know whether CD is a periodic frequent pattern or not. Is CD a periodic frequent pattern? Let me know. Okay, any other answers? So Edward is periodic or not? Yeah, okay. CD is a, yes. So CD is a periodic frequent pattern. Okay. So what we have to do is we have to find all periodic frequent patterns in the data. I have one question. Okay. Now answer this question to me. Design an a priori like algorithm to find periodic frequent patterns. Okay. So you have seen the a priori, right? It measures the count. If you want to find periodic frequent patterns, what changes you have to make to the a priori algorithm? Okay. So let's go back. I will show you the a priori. So, okay. So this is the a priori algorithm. Okay. So in a priori algorithm, we are currently maintaining the support only, right? If you want to find periodic frequent patterns, okay, what changes do we have to make in this algorithm? How do you change this algorithm? So any ideas on how to change this algorithm? Okay. There are two fields here, right? Okay. So how do you change? You cannot store all the timestamps here, right? In one field. So how do you change it? How do you change this list structure? It's very simple. No. How do you change it? Any other ideas from anyone? I'm coming back here. Okay. I am typing the message. Okay. One way is I will store like this. Item set. Okay. Instead of support, what I can do is I will maintain list of timestamps. Okay. Will this be sufficient? Think. Okay. Let us see how we can do it. Okay. So I am giving one more example. Okay. Example is A. Okay. So what are the timestamps in which A has appeared? 1, 2, 4, 7, 9, and 10. Okay. So once I have this information, okay, I have to just go through this list. Okay. The size of the list is support, right? The length. Okay. This is array. So just if you ask the length, you will get it. Then using one for loop, you can find the periodicity of this pattern. Okay. Next, let us do it for B. Okay. B. So B appeared at 1. B appeared at 4. Okay. B appeared at 5, 7, 9. Okay. So support is 5. Okay. Now if I want to find for AB, okay. Now what I can do is I will do the intersection of these two. Okay. So I don't have to scan the database. I will do the intersection. Okay. So how do you do the intersection? When you, okay, A intersection B. So which is 1, 4, 7, and 9. Okay. So this will give you the support, and a scan on this list will identify whether it is a periodic frequent pattern or not. It's so simple. Okay. Now I am asking you one more question. Okay. A pattern. Okay. Let us take AB or for XY. Okay. Let us take a different database. Appeared at 1, 4, 5, 7, 9, 10. Okay. Max per is 2. Okay. Let me know the strategy. Okay. To identify XY as aperiodic as soon as possible. Okay. So I am giving you this list of timestamps. Okay. Maximum period is 2. Okay. So we know. Okay. Let us put one more here. 20. Okay. Now you can see the maximum gap here is 10. Okay. So XY is a aperiodic pattern. Okay. The traditional approach is you find the periodicity and then you determine XY as a aperiodic pattern. Okay. Which is a very time consuming process. Can you identify XY very fastly? Okay. Okay. Let us talk about the complexity. Okay. What is the worst case complexity of this periodicity measure? It is order n, right? Because we have to scan entire list to identify. Similarly, the best case is order n. Okay. Can we reduce this complexity efficiently? How do we reduce it? These are all top class research problems. You can easily publish in top tier conferences and journals. Can you reduce this complexity? No idea? It's very simple. One strategy is greedy search. Okay. So what we can do is we take 1. Okay. So we calculate the periodicity. 0 minus 1 is 1, right? Is 1 less than 2? Yes. Then we come here, okay? 5 minus 1, that is 4, okay? 4 is greater than 2. So here itself, we know that xy failed to be a periodic frequent pattern, okay? So we can stop at this stage only. So when we apply greedy search, okay, then the worst case remains the same. But the best case becomes order of 1. Okay. So this way we can significantly reduce the search space. This is very important because in the real world the timestamps can be in millions and you have to do the scan on this million, which is not practicable. So such techniques like this can significantly benefit us. Okay. So this is now let us look at the different topic. Okay. High utility patterns. This is a very hard topic. Many people are working on this one. So you can work on this one if you are interested. So let us discuss this topic. So here we have items. Okay. We have the notion of item set. And here we have a transactional database. Okay. With some value. Like for example, if we go to a supermarket, we purchase 3 quantities of milk, something like this, right? So you can say 2 quantities of A were purchased by the user, 3 quantities of B was purchased by the user, 2 quantities of F was purchased by the user. Okay. Next, we have the price. We call this as external. Okay. So items, number of purchases, and the price of the item purchases. So now the user, okay, wants to know which item sets have generated high revenue for the user. So how do we do this? Let us calculate the utility. So utility is a generic term. It can mean anything, okay? So what is the utility of A in T1? Okay, it's 2 into 200. So the utility of A is 400 in the first transaction, okay? Now, let us calculate the utility of item set in a transaction. So how do we calculate? Utility of AB in the first transaction is utility of A in the first transaction plus utility of B in the first transaction. That is 2 into 2, okay? 400 plus 3 into 3, 300. Excuse me. So that is 900, okay? The total is 1300, okay? So this is the total price of item sets AB in the first transaction. Excuse me. Hello? I am in the class, okay? So AB is there. Now what we have to calculate is what is the utility of AB in the entire database. So let us see where the AB has appeared. AB has appeared at 1, 3, and 5. So utility of AB in the first transaction plus utility of AB in the third transaction plus utility of AB in the, sorry, this is 5, okay, in the fifth transaction. So it is the sum. Okay, that is 3000. Now we say a pattern as high utility pattern if its utility value is more than the minimum utility value. Okay, so if minimum support is 2 and maximum utility is 2600, then we say AB as a high utility frequent item set. Very simple. Okay, now let me know whether CD is a high utility item set or not. Please calculate the utility value of CD and let me. Okay, calculate for CD. CD has appeared in 2, 4, 5, and 6. So please calculate the utility of CD in the entire database. Utility of C in the first transaction is 200 plus 1200. So the utility of AC in T2 is 1300 plus here it is 400 plus 1200. So here itself the utility of CD is more than the user specified threshold. Are you guys typing? Okay. So correct. So the utility of CD is more than the utility of value minimum utility specified by the user. So it is a high utility pattern. So what we have to do is we have to find all such patterns in the data. Now coming back. Okay. Now let us look at the fuzzy periodic frequent pattern. Okay. The same case. Okay. So in Japan, we have aging population whose major health problem is cardiorespiratory problems. Okay, and the major cause is air pollution. So we have the network, okay, which generates the data. Now, okay, the environmentalist has this question, okay, find geographical areas in which people were regularly exposed to high levels of an air pollutant. Okay, you have to search it. So if I give this data to the previously discovered periodic frequent pattern mining algorithm, okay, what it will do? It will give us the error. The reason is it can handle only binary data. It cannot handle quantitative data. So what we can do is we can convert this data, okay, using fuzzy sets. Okay, so let us briefly see what is a fuzzy set and how to solve it. Okay, okay, these are the Japanese government has specified these categories. Okay, for PM 2.5, if the value is less than 10, we say that air pollution is within the limit, so it's good air. Otherwise, it is moderate air. Otherwise, we say air pollution is unhealthy for selective groups, then unhealthy air, and so on. Okay, look at these values. Okay, now what we say is, sorry, we create a fuzzy membership function. So the 10 here, so this is good. So moderate starts from 11 and ends at 15. Okay, so 15 is moderate. Similarly, 35, 50, and 70. Now what we do is we give a fuzzy function for good. Okay, good is from 0 to 10. Okay, so for value 0 to 10, the value is good is 1. Okay, if the value is more than 10, okay, then what we do is we are decreasing the value of good to 0. At the same time, moderate will increase from 10 and reaches peak at 50, and it goes until 35. So like this, we construct fuzzy equations. Okay, these are all fuzzy equations. Once we have these fuzzy equations, what we do is we convert the temporal data into fuzzy temporal data. Okay, so let us look fuzzy. Okay, it is 60, right? So A's value is 60. This is lying exactly in between UH and VUH. Okay, in between. So we say A dot UH weightage is 0.5, A dot very unhealthy, okay, value is 0.5. Now look at B dot UH, okay, B dot UH, B value is 65. So the value is here, okay. So what we say is B dot UH weightage is 0.25, B dot very unhealthy is 0.75. So this is the weightage. So we derive such weightages. Now what we do is, so this is our database. We applied fuzzy membership function on this database, and we got something called fuzzy temporal database. Okay. Once we have this fuzzy temporal database, now we calculate the support. Okay. So when we are calculating the support, okay, we calculate the sum. So item D dot UH appears in the timestamps of 1, 4, 5, 8, 9, 10. So we sum up the values. Okay. And when we sum up the value, the derived value is the support of the of an item in the data. Now when we are talking about the support of a pattern, okay, we take the lowest weight. Okay, so what is the support of AB? The lowest value of here, the lowest value here, the lowest value here. So we collect the lowest values and we sum them up. Okay, that will give us the support of the pattern. Now, what we say is a fuzzy pattern is said to be a fuzzy frequent pattern if its support is no less than the user specified minimum support. In this case, we get the fuzzy pattern A.UH and D.UH. Once we know it, then what we do is we take the timestamps, we calculate the periodicities, okay, and then we take the periodicity. Now, if the period, now, okay, if the user specified periodicity is 4, then we know the periodicity of this pattern, okay, A.UH and D.UH is less than maximum period. So we say this as a fuzzy periodic frequent pattern. Okay, so our objective is find all fuzzy periodic frequent patterns in quantitative temporal database. So this is our objective that we try to achieve. Okay, so the problem definition is very simple. Given a quantitative temporal database, set of fuzzy membership functions, minimum support, and maximum periodicity constraints, we try to find all patterns in a quantitative temporal database that have support no less than minimum support and periodicity no more than maximum periodicity. So this is the another model. Okay. With this, I have completed my presentation. We have some time, so let us look at the example. Okay. Here I have given you the fuzzy values. Okay. Now please calculate the fuzzy value of A.VUH plus B.VUH. What is the support of this pattern in the entire database? I have kept the database here. I am typing the message here. Okay. Calculate support of so let me know the support of this one. Okay. So the above pattern should have appeared in these timestamps. Okay. Now find the lowest value and then give me the reason. Does not appear in file. Okay. Yeah. Sorry, my bad. It appears in 4 transactions. Yeah, Edward is correct. So the value in the first one is 0.5. Okay, then in the 4, yeah, 0.5. So 5 is not there. So 9, 0.5. Yes, the last is 0.25. The total is 1.75. Right. Okay. So this, what is the minimum support value? Is 2. Okay. So this is a uninteresting pattern for us. We delete this pattern. Okay. So we can clone such uninteresting patterns in our model. So any doubts in understanding any concepts? If you have any doubts, let me know. Okay. So I end my presentation. So let me know if you have any questions. Or any suggestions are also welcome to improve the lecture. Okay, so no questions. Okay. Fake sensor. Okay, then if you don't have any questions, okay, let us end this class. Okay, yeah, and if you get questions in later, okay, please message me to my email. Okay, thank you very much. I will end the meeting now.
Okay.
Since mine is finished, so
Okay. Please off the recording.
yes.
Okay.